Welcome to Frequency Matters, the RF and microwave update series. I'm Pat Hindle, and I'm here with my co-host Gary LaRue. In this episode, we're going to cover our September millimeter wave components and packaging themed issue. The cover feature is written by authors from CEA Leti, covering spectrum above 90 gigahertz for wireless connectivity, opportunities and challenges for 6G. They discuss the various semiconductor technologies available for devices at these higher frequencies, looking forward to the future 6G technology. What did we have for technical features, Gary?
Well, we have a good mix this month. On the millimeter wave theme, PRFI has an interesting article describing the implementation of a full Doherty PA MMIC at 28 gigahertz for 5G. Then Cubic Nuvotronics has written a survey of packaging technologies for millimeter wave antenna arrays. From Cinematrix, an article describing a ceramic waveguide filter design using computer-aided tuning. Anlotech writes about the design of a Super Nyquist direct digital synthesizer. And our Fabs and Labs feature this month visits Ericsson's new automated 5G factory in Texas, which is building millimeter wave base stations for Verizon.
So I wanted to mention that we're now posting online-only features each month, and they go with the issue and are listed in the TOC. I recently published an online feature reviewing the leaders in millimeter wave semiconductor testing technology, including systems from Anritsu, Focus, FormFactor, Keysight, Mari, NI, Roden Schwartz, Ruse, and Teradyne. So a lot to look at there. What were some of the other online features we posted recently, Gary?
Well, we have one from Menlo Micro, which is a MEMS switch manufacturer, and they've applied their MEMS switch technology to design a miniaturized high-power UHF tunable filter using what they call an ideal switch.
So turning to the news, there are a few developments in the area of 5G. ZTE and MediaTek announced that they completed the industry's first 5G carrier aggregation of 700 megahertz and 2.5 gigahertz based on commercial terminal chips in China. Also, Qualcomm and Ericsson completed interoperability tests to enable operators to implement 5G carrier aggregation. The partners completed 5G standalone carrier aggregation testing in Ericsson's labs in Beijing. The connection reached 2.5 gigabits per second peak speeds by aggregating 100 megahertz and 60 megahertz within the 2.5 gigahertz TDD band in the 70% downlink configuration and using 4x4 MIMO. In addition, the companies conducted a carrier aggregation test in Sweden where they established a successful 5G standalone carrier aggregation data call by combining 20 megahertz in the 600 megahertz FDD band with 100 megahertz of spectrum in the 2.5 gigahertz TDD band. So lots of carrier aggregation going on. It's really kind of the way that we're really speeding up the networks. ZTE also announced that they have completed a trial of the automatic antenna pattern control self-optimization solution. They used AI technology to simplify the optimization where they're able to improve the network coverage by 12%, and the signal strength was increased by 4 to 5 dB, so a significant improvement there. What did you see in the news?
Well, the FCC's auction of 70 megahertz spectrum at the 3.6 gigahertz CBRS band raised some $4.6 billion. Verizon, which needs sub-6 gigahertz spectrum for 5G, spent $1.9 billion for 557 licenses in 157 counties around the country. And Dish Network, which is entering the U.S. cellular market as the fourth nationwide carrier, needed to establish a national footprint, so it spent $900 million for almost 5,500 licenses in some 3,100 counties. And then interesting, AT&T, which already has low-band spectrum that complements its millimeter wave holdings, did not buy any licenses. Then the second item, the Starlink constellation is now more than 700 satellites orbiting the Earth, and parent SpaceX says download speeds are better than 100 megabit per second. That's greater than the early reports we saw from beta users who were reporting in the range of 36 to 60 megabits per second down, and 5 to 18 up. SpaceX also says it is testing an inter-satellite laser link between two satellites, and if this works and it's deployed widely, It would enable data to be relayed from satellite to satellite across the constellation.
So turning to events, I don't think we'll be seeing many in-person events for the rest of the year. However, our EDICon China event is still planned to take place October 13th and 14th in Beijing and is still on for local participation as mainland China is open for business. Looking ahead to next year, CES has already announced that they will take place virtually, but our European microwave event is planned to take place in January in Utrecht in the Netherlands, providing that's still open, and I think we're seeing that could be the case for now. If things don't work out in person, though, we'll be preparing for any kind of virtual scenario that's needed.
And we're under a month from EDICon Online, which will be every Tuesday in October, starting October 6th. The theme that day is 5G, IoT, and automotive. Then the following week, it's PCB interconnect design. October 20th, we focus on signal integrity and power integrity. And we wrap up the month on October 27th, focusing on radar and antennas. There's no charge to attend, thanks to our sponsors, and you can receive continuing education units for any sessions you attend. You can see the full program, which has more than 40 sessions, and register for those that are of interest to you at edicononline.com. Well, that wraps up this episode. We want to thank our sponsors, RFMW, a premier pure-play technical distributor of RF microwave products, and Wireless Telecom Group, which is comprised of Boonton Electronics, Holsworth, and Noisecom, well-known names in test and measurement, and Com Agility and Microlab, suppliers of RF microwave components and wireless subsystems. Thanks for watching. Until next time, remember, frequency matters.